Okay guys, we're going to try to do some video notes today because the snow days kind of messed up our sub plans, but we're going to do this. It should be easy stuff today. It's actually pre-calc stuff today, but it is stuff you didn't cover in pre-calc, so we need to hit it before we move on. If you had physics, it should be pretty straightforward. You've seen vectors before, so if you haven't had physics, don't worry, we're going to cover them from scratch and what we need to know with them. But everybody should be ready to take notes and be going along with me. You can ask the sub to stop if you need to pause, because it's kind of hard to judge how quickly I'm going if I don't have students in here. But let's jump in. Okay, so what is a vector? A vector shows length and direction. If you guys have seen Despicable Me, I think there's stuff in there with the bad guy Vector. Magnitude and direction, I'm not sure if that's what he says. Well, let's go ahead here. So like this vector right here that I can see, this one, it has a distinct length. So it doesn't, even though it's an arrow, it does not keep going. Okay, so this arrow here, let me get my magic pen here. This arrow implies that it keeps going. Stop it. Okay, but it doesn't. It actually stops. So this is actually right here. This is called the initial point. And actually, let me get rid of my magic pen and go to a normal pen. So this is called the initial point. And this is called the terminal point. Now, also called start and stop. That's basically what it means, start and stop. So we have a start and stop. In physics, you refer to them as heads and tails, or maybe heads and toes, because when you add vectors, which we won't get into, that is a pre-calc kind of thing. You have to line it up head to toe, okay, or head to tail, however you want to look at it. But so we have a start and a stop. So if I scroll down, I have all these different types of vectors. So if I'm looking at this one right here, it has a clear start. It tells me the direction, so it looks like I'm going a little bit southeast. Okay, so it will tell you direction in an angle. Okay. Same with this one. I have a start, so it looks like I'm going a little northwest at a certain angle. So there are two unit vectors. Now remember what unit means. Unit means 1, which means it has a length of 1. It's kind of like in a coordinate system, how you have x and y, and you have 1 on each scale. Same thing. Our I vector is just a vector along the x-axis that has a length of 1. Okay. Same with the j, that is along the y-axis. Now we can get more in depth into this, and maybe we will after the AP test if we have time. But there is a third one. There is the k vector, which goes along in the z-axis, so in the three-dimensional. So if you've seen physics, I'm not sure if you get into that kind of stuff. Okay, but we do need to know that because all vectors are a combination of I and j. So we can tell you, we can describe a vector as in how many ways it goes in the x and how many ways it goes in the y, which is our I and j components. Now we can write them in two different forms. We can use these carets here. This is called component form. I'm sorry, my pen is just not quite working here. Component form. Or we can write AI plus B times J, and that would be linear form. So this vector right here, I can write it two different ways. So notice it goes 3 on the x, so that would be 3I plus, and on the y, it looks like it goes 5, so 5J. That's linear form, or I could just write the coefficients 3, 5, and that's component form. Now depending upon what we're doing, each form has a different benefit, because when we get into things like dot products, cross products, those are really cool stuff that we don't really get into until after the AP test. But that's stuff that, depending upon what form it is, it makes it a whole lot easier. So we can write a vector based on its start and stop points, initial and terminal point. So let's say P is the initial point, Q is the terminal. So I have 2 points. Okay. I can find the vector by simply subtracting the x's, because that gives me the distance along the x-axis. And I can subtract the y's, and notice they are those carets because we have a vector. Now sometimes you will see books or by hand draw that little arrow above vector v. We just gave it a name. And they kind of just saying, hey, that's a vector with that little arrow above it. Some books will just bold the letter V and say that it's a vector. By hand, we tend to write the arrow because we can't really bold very well by hand. So another vocab word here is magnitude. Kind of used that word before when I talked about Despicable Me. It's just another word for length. So it's kind of the big kid word for length. So instead of saying length, we usually use the term magnitude. It's the distance, how long the vector is. Okay. Notation-wise, we tend to use what looks like absolute values. However, some books will use the double struck. Okay. It kind of just depends on the book. Usually it's told the magnitude, so it's pretty clear what we mean. But it's not absolute value. Not really. It's very similar. Actually, the distance of absolute value, if you look at a number line, we all know is the distance from 0. But that's on a number line, which only has one left and right. So it only has the one option there in the directions there. However, if we look at up and down as addition to left and right, this is actually the definition of absolute value because it's the Pythagorean theorem. It's that distance from 0. So let's do a couple here. Let's find the magnitude of vector PQ given the initial point of P, the terminal point of Q. Now you can kind of graph this if it helps you. But what's really going on, and we don't need to do this, I'm just going to do a little sketch so you see the idea. The 3, negative 1, there's P. Negative 4, 2, there's Q. So that's our vector that we're looking at there. That's a Q, believe it or not. Okay. Doesn't really need a picture, but if you want to visualize it. So we're going to write it in component and linear form. So all I do to find vector PQ, and this is really hard to write on, so be patient, is I subtract my x's. So negative 4 minus 3, subtract your y's, 2 minus negative 1. I end up getting negative 7, 3. That's component form, but it said also linear form, so I have negative 7i plus 3j. And there we go. That's all there is to that question. Don't think it asked me, oh, nope, sorry, I need to read. Find the magnitude of the vector. So I found the vector, now let's find the magnitude. So the magnitude of vector PQ is the square root of negative 7 squared plus 3 squared. This pen is driving me nuts. Which give me the square root. Well, here I'll get 49 plus 9, so 58. Let's see if that reduces. Divide by 2. Let's see, we'll get 29. Yeah, nope, doesn't reduce. And so just magnitude is the square root of 58. Sorry for the handwriting. It's really hard to write on this pen. It's not working very well. Okay, so here's some pretty easy questions. You have a bunch of these in homework. Let's let U, that is a vector, so if you want to draw the arrow above it, you can. It is the vector negative 1, 3. We can tell it's a vector by the component form, the carets there. And V is 4, 7. We're going to find the component form of other vectors. So here we want U plus V. Well, that's pretty straightforward. We just add our I components and get 3. Add our J components and get 10. Voila. 3. It's really hard to write. Okay, so 3U, well, it's just taking your U vector and multiplying by that scalar. That's what we call that when we multiply by a number and a vector. So we end up getting negative 3, 9. Next one, 2U minus V. Well, first let's find 2U. So 2 times U will give me negative 2, 6. 6. Come on. Minus, let's see, vector V was 4, 7. Goodness. Okay, so negative 2 minus 4 is negative 6. 6 minus 7 is negative 1. There we go. Last one, I want the magnitude of vector 4V. So let's first find 4v. Okay, so multiply by 4. Let's see, I'll get 16 and 28. Oh my goodness, I cannot write. Okay, so 16, 28. Now we need to find the magnitude of that. So square root of 16 squared plus 28 squared. Sorry, this is not writing very well. That's pretty big. I'm going to grab my calculator really quickly. And we're going to, some of these are calculator active, some are not, so make sure, oop, uh-oh, that's not good. There, great. Hold on. Pause. Okay, sorry about that, disconnected for some reason. But you all, of course, have had time to do this on your calculators now. We end up getting, let me scroll down, 4 square root of 65. So now you try, you find the magnitude of negative 2u plus v. So I'll give you a minute. Of course, we're not clicking in, but you work this one real quick for a minute. And I'll figure out what's going on with my board while you do that. Okay, my pen's not cooperating and dropped my negative. We should get the square root of 37. Square root of 37, which of course does not reduce. Alright, let's get to the good stuff here. This is the big stuff for the AP test right here. Component form of a vector, we can easily find it without a graph just by knowing the magnitude of the vector and your angle. Okay, your angle. And of course we are talking angle in terms of unit circle. So your angle starts here, that's 0, that's 90, 180. So we still have to use our same directions. Okay. Notice it's cosine first, then sine, just like the unit circle. So we're going to find the components of a vector with direction angle 115 and magnitude 6. We're going to sketch the vector. Okay. And I might see if the pens up here work a little better than me writing on the board. My computer, it's just not working very well. Okay, now it is important when I say sketch the vector, it's just a tiny little drawing, it's not graph paper, but it is important because we will get answers that don't make any sense. We have to use a little common sense of our own. So we know that the angle of 115, okay, we know that that's 90, so it'll be somewhere over in quadrant 2, right? So when we get an answer, we better have a point, if you will, that's in quadrant 2. So we're going to start off, we know the component forms are magnitude of V cosine theta, magnitude of V sine theta. Okay. So all I need to do is find the magnitude here. Magnitude is already told, 6. Angle is easily told, 115. So 6 sine of 115. Now we're just going to use our calculator calculators, but be very careful. Notice I am inputting degrees. Okay. Remember, we are covering pre-calc stuff today, which is why we're in degrees. All the other rest of the time it will be in radian. So be very careful on your mode. So everybody make sure you go to your home screen. We're going to change our settings to degrees just for today. On a quiz, it will say make sure you're in degree or radian mode. I'll kind of help you out on that front. Okay. So I have officially changed mine to degree mode. So I just type in 6 cosine 115. I want 3 decimal places. Negative 2.536. Then I have 6 sine 115. So I have 5.438. And it's that simple of a question. No tricks. Just plug in your magnitude, plug in your angle, use your calculator. But watch your mode. Okay, so let's do another one. And apparently I'm definitely not aligned. So same thing, we're going to have, oh, by the way, let me check this real quick. Notice this is in quadrant 2. Negative 2, 5. So we're good to go there. So on this next one, same thing. Let's just go start. I have magnitude, cosine of my angle. Okay, magnitude, sine of my angle. Now keep in mind 68 degrees. That should be somewhere in quadrant 1. So when we're all done, we better have numbers that are in quadrant 1. So let's go ahead and use our calculators. 4 cosine 68. Then 4 sine of 68. And there we go. Hopefully pretty straightforward. Because in a minute we're going to be going backwards, and that's the hard part. This stuff should be very easy. Okay. So quick you try. Find the component vector. If you have magnitude of 5, angle 315. Okay, so you get positive 3.536, negative 3.536. Notice it's the same term because it actually is on the unit circle. And we are in the correct quadrant because we're a positive x, negative y. You're in that quadrant 4. Alright, let's go backwards. This is the tougher stuff. We're going to now go backwards. We're going to find the magnitude and direction angle given the component form. Okay. Well, just to remember, let's first find the magnitude. That's super easy to find. That's the square root, 3 squared plus 2 squared. So I get 9 plus 4 squared, 13. So I found the magnitude. So that's really easy. It's the direction angle we need to be careful of. Now, we always need to sketch a graph. A little tiny, just a little tiny sketch over here. Nothing extremely important to be accurate or anything. We're just in the first quadrant. So we're at 3, 2. So somewhere in the first quadrant is where my angle should be. So I should have an angle between 0 and 90 when I'm all done. Okay. So now I know that the component form is the magnitude of V cosine theta, magnitude of V sine theta. So I'm going to use that. That if this is my x or my I component, if you want to think about it, that should be 3. So 3 should be equal to the magnitude times the cosine of theta. Okay. So divide, I have 3 divided by square root of 13 equals cosine theta. Take the cosine inverse, so this is what you should be typing in. I never usually write this. Type that in, and make sure you're still in degree mode. The cosine inverse, use your fraction button. There's no need to clean that up either because we're finding an angle. I have approximately 33.69. 0. 3 decimal places. Now, is that in the correct quadrant? Yes. So I can stop here. There's no need to do the same for my y. Because, let me scroll up. If I do that, I'm going to get the exact same angle. Okay? Or I'm going to get a coterminal angle, which I don't want. I want an angle that is on the unit circle. Okay? So 0 to 360. So make sure you're on the unit circle. And just make sure it's in the correct quadrant. Let's do another one. So here we have negative 4, 1. There should be negative 4, 1 will be somewhere in quadrant 2. So notice my answer should be between 90 and 180 degrees. So let's start by finding the magnitude. So negative 4 squared plus 1 squared. So I have the square root of 17. And let's start by doing my component form. Remember, it's magnitude of v cosine theta, magnitude of v sine theta. So I know that this square root of 17 cosine theta should equal my I term, which is negative 4. So cosine of theta is negative 4 over square root of 17. So use your inverse trig. And I got 165.964. That's in the correct quadrant, so there's my answer. But let me show you the sine one. I would have square root of 17 sine theta equals 1. So sine theta would be 1 over square root of 17. So I take that, do the inverse trig, and I get 14.036, which does not make any sense. That angle is somewhere over here. Now we could get this angle from this using symmetry, which we will in a minute, but when you do both, they aren't always needed. Which one is logical? Which one is in the correct quadrant? And the reason it gives me two different ones is because of our inverse trig. Remember, answers to inverse cosine will be on the top part of the unit circle. Answers to inverse sine will be on the right half of the unit circle, negative pi over 2 to pi over 2. So that's why we can get two different answers and only one makes sense. So here's about as tough as one as it can get. I'm going to do a little extra thinking. And the reason it's a tough one is because it's in that quadrant 3, so negative 2, 5, negative 5. And remember, cosine inverse gives us answers here, 0 to pi. Sine inverse gives us answers on negative pi over 2 to pi over 2. Nothing gives us answers in this quadrant, which is why we have to do a little symmetry, a little common sense there. Well, let's start off the same way. Let's find the magnitude. Negative 2 squared plus negative 5 squared. See, 4 plus 25 square root of 29. By the way, make sure you reduce that if it reduces. Okay? Your calculators do that for you if it is a calculator problem. Okay? So let's jump in here. I know that the magnitude times cosine gives me my I component. So I have cosine of theta is negative 2 over square root of 29. So let's find that. So cosine inverse, negative 2 over square root of 29. Get 111.801, which is in quadrant 2. Okay, not what I want. Let's do sine. So square root of 29 sine theta is negative 5, right? My j component. So sine of theta is negative 5 over square root of 29. Let's find sine inverse, negative 5 over square root of 29. I get negative 68.199, which is in this quadrant, not what I want either. However, I kind of like that one better. You can use either or to get your answer. I kind of like the one that's in quadrant 4 usually. I think it's easier to see because that's at negative, this is negative 68.199. So I drew that kind of angle there. Well, by symmetry, it's going to be the same thing. So instead of going from 360 minus 68, that'll give us here, I can go 180 and add that same angle. See how it would be the same? So if I go 180 and I add that 68.199, I'm going to get where I want. Not the only way to do that. I can use my 111 and do kind of the same thing. But when I do that, I'm just going to take my answer here. I'm going to add it to 180. I get theta is approximately 248.199. And that is in quadrant 3. So the hardest ones occur in quadrant 3 simply because our inverse trig does not cover quadrant 3. So I still found both of my thetas, but then I had to use a little picture in symmetry. If that's 68 degrees in this direction, it's going to be 68 degrees in the same direction on the other side. So I just went from 180, add that 68. Now some people are like, what about it's negative? Well, if I subtracted it, it's going to be up here. I don't want that. So a little common sense comes into play. Last is a U-try. So go ahead and take a moment. I'll work it while you do. Find the magnitude and direction angle. Okay, let's go over this. We all should have gotten the magnitude of the square root of 73. Now, I really didn't need to do the cosine if I thought this through, because notice how I'm in the fourth quadrant. Well, cosine inverse is only going to give me 0 to pi, 0 to 180 in this case. So cosine inverse is not going to give me my correct one. So I could go straight to the sine inverse. Now, yes, negative 69.444 is correct, but I did ask for one that's on the unit circle, right? Unit circle is 0 to 360. So just add 360 to get that coterminal angle of 290.556. And why did my decimals change? Unless I wrote it wrong. No, oh, this is negative. Never mind, I'm good. Alright, and one quick thing then, if I can get this to go. Derivatives of vectors, super duper easy. All you do is take the derivative of each piece. So if you want to know if you have, especially velocity, we're going to get into that a little more tomorrow. We have x and y components. You simply take the derivative x prime, y prime. It's very straightforward. Okay? So if I can get this to move. Did I skip one? No. So particle moves in the plane, so its position at any time greater than or equal to 0 is given by sine t squared over 2. Okay? Find the position vector. This is a really weird question. People overthink this way too much. position vector. Notice this is a point, parentheses, okay? And by the way, we start at 0. It's assumed it's starting at 0. It's the easiest way to do that. So our vector is just the same thing, but with carets. It is now a vector going from 0 to that. Okay? So you can look at it as this is my terminal point, and I had an initial point of 0, 0. Remember, we could subtract this minus this to get my vector. That's the easiest way. Now, it doesn't have to start at 0. That's certainly the easiest thing to use, though, so I don't know why you'd use anything else. So find the velocity vector. Well, that's just a derivative. So the derivative is cosine t. Multiply and get t. Find the acceleration vector. Well, it's just another derivative. So negative sine t, 1. Now part D is really weird. It says describe the motion and the particle at t equals 6. Now we start wanting to go in left, right, everything, but vectors aren't that straightforward. We're going to get a little more into that tomorrow. So when the AP test asks you to say describe the position and motion at t equals 6, all you're doing is plugging in t equals 6. Okay, we're not actually explaining in words any motion. So if I want to plug in the position, let's plug in 6. Okay, and I don't know, they don't tell me if I want to be in degrees or radians. Let's see, they don't tell me. Well, then I'll just take the cheap way out. I'm not going to give a decimal at all. So plug in 6, I'll get sine 6. And then plug in 6 to your y value, your position, if I can get this to scroll up. So let's see, 6 squared 36, 18. There's my position vector at t equals 6. Now motion, they want you to recognize that means velocity vector at 6. So there's my velocity vector. I'll get cosine of 6. 6. Boom. We're not really describing the motion just yet. It's a little more intense, which we'll get into tomorrow. But right now, you should just be able to find the derivatives and plug in. Okay, so quick U try. Find the velocity and acceleration vectors if the position vector is given by that. So quick U try and we're done.